Ever tried to describe something you know, like the name of that one song stuck in your head, but it's just out of reach? For millions with language disorders like aphasia, this isn't a fleeting moment of forgetfulness. It's a daily battle. But what if AI could help bridge that gap? Today, we're diving into how researchers are teaching machines to guess what you mean, even when your words are all over the place. Let's start with a problem. Imagine someone trying to say Cinderella, but ending up with slipper or princess. These are semantic paraphasic errors, words that are close but not quite right. Then there's the bigger hurdle, unseen terms. The real word they're trying to say, like Godmother, might not even show up in their description. It's like solving a puzzle with missing pieces and red herrings. So how do you teach a machine to handle this mess? Researchers developed GradSelect, a method that lets AI think through confusion. Here's the trick. They used gradients, the AI's internal confidence scores, to decide what to keep and what to toss. For confusing words, the SPEs, they added noise to make the model more resilient. But here's the twist. They didn't just randomly mess with the text. They focused on words the AI was unsure about, those with low gradients, while protecting high-confidence words that kept the description on track. And for unseen terms, they borrowed a technique from search engines called pseudo-relevance feedback. Think of it like this. If you search for best pizza in town but type best pie in town, a smart search engine might still show you pizza places by guessing your real intent. The AI did something similar, using top results to expand the description, adding words like fairy or magic to fill gaps. The results? The model's accuracy jumped by over 40% compared to older methods. When tested on real patient data, it showed real promise for helping people with anomia communicate more effectively. This isn't just about AI, it's about empathy. By understanding language disorders, researchers are creating tools that could one day make conversations easier for millions. So next time you struggle to find the right word, remember, science is working hard to ensure no one's voice goes unheard. But here's another twist. What if we let AI guess words without rigid rules? Traditional training often relies on hints like, this word has 7 letters, but humans don't think that way. We don't need letter counts to figure things out. So researchers asked, what if we let AI guess words freely? Their answer? A universal placeholder, a single mask that works for any word no matter the length. Think of it like a wildcard in Scrabble, flexible, intuitive, and closer to how we process language. But how did they test this? They pitted it against other methods. There's Cutoff, which randomly chops sentences to create new examples, like editing a story by snipping paragraphs. Then EDA, which swaps synonyms, adds random words or shuffles phrases. It's like rewriting a paragraph with a thesaurus and a sprinkle of chaos. Next, Smart, which adds virtual adversarial noise to data, subtle tweaks to make the model more robust, like teaching it to spot a cat even with static. And VDA, which generates similar but fresh data variations. Think of it as creating new melodies from a familiar song. But here's the clever part. Instead of just testing these methods, they fine-tuned them. They adjusted parameters like alpha and beta. Think of them as dials controlling how much noise or change gets added. For example, in their circumlocution augmentation, a fancy term for guessing around a word, they found the perfect balance by tweaking those dials. The results? Their approach outperformed the competition, especially in tricky cases like ambiguous phrases. A statistical analysis showed it was significantly better than previous methods. Take the Reddit Tomp dataset, where users describe movies without using the actual title. The old method Cutoff mistakenly suggested Hollow, a horror film for a query about a documentary or book, but the new model. It nailed the context, avoiding that kind of confusion. So what's the takeaway? By letting AI think more like humans, without rigid rules or letter count hints, we're building smarter, more adaptable language models. And that means better conversations, clearer answers, and systems that actually understand what we're saying. Thanks for watching. If you want to learn more about AI in healthcare, hit subscribe, and let me know in the comments what topics you'd like to explore next. Until next time, keep talking, keep learning, and never stop wondering.